All right, I think we're good. Let's get started. All right. Hi, everybody. How's everyone doing? Good? Not day one, Expo Day 1 energy, at least for me. Hi, my name is Ashley Alicea. I'm an evangelist for Unity Technologies based in San Francisco. A lot of what I focus on are using Unity for video games and media and entertainment, so things like film and more. So I am curious. I want to get a gauge of kind of what everyone here knows about Unity. How many people here use Unity? Raise your hand. A lot of you. Excellent. Okay, cool. How many of you are artists? Okay. Programmers? Okay. Mix of both or something else? All right, awesome. Okay, cool. Awesome, fantastic crowd here. So all of you are going to learn something really cool. But today I'm really excited to show Unity's visual effect graph. Now, one thing before I start my presentation, I want you guys to notice my PowerPoint doesn't look so much like PowerPoint. It's actually Unity. My slides are in Unity. And what I'm doing is that while I'm presenting to you all, I'm actually presenting a live Unity project. So all the examples that you're seeing here while I'm presenting are live in real time. As you can see, I'm rotating around. This is all happening in real life, in Unity as I present to you today. So let's go ahead and get started. All right, so what is the visual effect graph? Have people here used it? Anyone here? Okay, yes, awesome. So visual effect graph is basically the next generation tool within Unity for creating stunning visual effects in real time without having to code. So it's actually a hybrid stack node-based system that you can use to drag and drop behaviors and data and more to build up a really cool looking effect. Now, not only can you drag and drop to create your effects, but it's also programmable. And you can use that to extend what you can do with the visual effect graph. Now, when you work with the visual effect graph, it's actually a self-contained asset file within your project folder, which means that you can use it again and again in your projects as a reference or more. And do note that right now, visual effect graph is tailored for platforms and devices which support GPU compute. So that's going to be your higher end computers, your consoles, and maybe like super recent mobile devices. But setting up the visual effect graph is super easy. How many people here have used Unity's package manager? Okay, if you haven't used the Unity package manager, check it out. It's a great way to get tools and updates that we're working on into your Unity editor really easily. You don't have to go like find the project on GitHub and go download into your project. So you can download the visual effect graph directly through the editor by going to Window, Package Manager right here. You get a window like here below. And just select the visual effect graph, and note that you also have to download the HD render pipeline because that's required to run the visual effect graph. This is working in Unity 2018.3 and above. And do note, when you install it, go into your preferences, this is my pro tip, and enable experimental operators because it's going to give you access to a lot of cool additional features like GPU events when you're working on your effects. Now, again, key points. Very artist-friendly tool. You can create really cool effects without having to code. And if you've worked in visual effects before, like who here has worked in Houdini or kind of other types of software like that to create effects? Okay, so a lot of your skills are transferable to a visual effect graph. Now, we unlock a lot of power with this tool because we're using GPU-based particles instead of CPU-based particles. And I'm going to dive into those differences in a minute. But what also is cool about it is the scalability of the effects that you can create. You can create anything from little small puffs of smoke to a big complex orb like we have here, or more samples I'm going to show you that can get really cool and complex. Now, this follows industry trends. Like I mentioned, if you work with things like Houdini, you're going to notice a lot of similarities because we're trying to align this tool to be familiar for those who have that kind of skill set. And lastly, we're able to have such gorgeous graphics because we're taking advantage of Unity's custom render pipeline, specifically the HD render pipeline. Now, the biggest question that I often get from people are asking me, so this is a particle system, right? Is it different than Unity's original particle system? So the key differences between both are that the Unity's original particle system runs on the CPU, while the visual effect graph runs on the GPU. So what does this mean? So using the particle-based system, we can have thousands of particles, but by unlocking the power of the GPU with visual effect graph, we can have millions. We can do simple simulations with particles, like that smoke effect that's happening there. But we can actually do really complex simulations with visual effect graph, and they look really realistic as well, being able to do complex simulations like for fluids. Now, there's still some benefits to using the particle system. If you need to have your physics, for example, or your particles interact with physics, you're going to want to still use the CPU-based particles because Unity's physics system is running off of the CPU. So it's going to be easier for the particle system to talk to the physics and back. You can do some basic physics with the visual effect graph by using things like primitives, sign distance fields, and depth buffers. Another benefit to using the particle system is that you have gameplay readback. So if you need your particle to affect aspects of your gameplay and more, it's still good to consider using the particle system. You can do this now with the visual effect graph, but what you can achieve with it for now is small, and there's going to be some latency. And another cool benefit of the visual effect graph is that you can use it to ready frame buffers. Now, what exactly makes up a visual effect graph? So in your graph, you have what we call contexts. Contexts are the containers that you for your information that help dictate the behaviors through each step of the process. Now, basically, this is kind of like when you program, right? So you have your spawn context. This is all the behaviors that affect your visual effect graph when it is created in your scene. Then we have initialize. This is similar to your start function in your code, right? So everything, all the behaviors that happen to your particles once they start will be put into the initialize context. Same with update. Just like update in your code, what behaviors are happening to your visual effect graph on each frame update? And lastly, the output. There's several different types of outputs in the visual effect graph, but basically they determine what your particles are actually, like how they are rendered, what they actually look like. Now, contexts are nothing without blocks. So by filling those empty contexts with blocks is how you can start dictating the behaviors that you need to start building up your visual effect graph. Now, we can add, there are hundreds of different types of blocks that you can add to your graph, and you can use nodes to customize the behavior of each block to really get specific and customize how your effect is created. Now, supported file types. I promise that's not a warning. I just thought it looked really cool. So the visual effect graph supports assets that allow you to represent volumes, forces, collisions, more. And it does so by being able to use things like point cache data, vector fields, and sign distance fields. So instead of telling you how cool it is, I'm going to jump into a live demo instead and show you how to create your first kind of basic visual effect graph. And I love this one because these butterflies are all done in the VFX graph, but it's actually one of the most complex ones out there, so it's really cool for me. So let's go to, all right. So I have a blank Unity scene here. Now, I have some basic HDRP settings to have like the procedural background, but that's it. Otherwise, it's a completely empty scene. And what I'm going to do in my project folder is that I'm going to right-click, create, and go to Visual Effects, and select Visual Effect Graph. And now I'm going to call this one SIGGRAPH. So now I have my Visual Effect Graph asset, which I can then just click and drag and take it and add it right into my hierarchy, like a game object. And now you see I have my template visual effect graph there. So anytime you create a new visual effect graph, you're just going to get the same exact effect. And then you could jump in and customize it for your needs. So I've opened it. I'm going to zoom in a bit here so you guys can see it better. And here on the side, I have my visual effect graph window, which I'm going to navigate through to start updating my effect. Now, the first thing I want to do is I want to think about, what are we going to make? And one thing I thought, I wanted to make something that can be achieved in a couple of steps, but that looks really cool so you guys can see how to build up those nodes and those blocks and more. And I thought, okay, let's make a cool fireball effect. So what do we need to do? We need to have our particles kind of form a sphere. We need to kind of have them flare out. So let's build through that process. First, I need way more particles. So the first thing I'm going to do is I'm going to up it from a spawn rate of 10 particles to 25,000. Now, I changed it to 25,000, but you notice that it hasn't added more because my capacity is still only set to have 32 particles at any given time. So what I'm going to do is I'm going to up that capacity to 65,500. And now we have a lot more. Notice how all of these changes are happening instantly as I update the visual effect graph. It's really great when you're just making changes to see what's happening instantly and go, wait, no, I don't like that. Let me go back and change it to be something else. You have a lot of flexibility to do that. Now, next part thing, I'm going to adjust the balance to make sure it's centered here. Place this to be at 0 and keep the size at 2. And then what I want to do is I want to remove the set velocity random, and instead I want to position everything to be a sphere instead of the square that we see. So I'm going to delete this block, just click on it, press delete. To add a block, I can just click on my initialize context and press space. It opens up a little menu that I can use to either navigate and search for what I want, or I can type it manually. So in this case, I want to create a sphere. So I'm going to use position sphere. And there we go. I have my particles spawning out into a cool, perfect spherical shape. So I have the nice base for my fireball effect. Now, like I mentioned before, I kind of want it to flare out, right? So what do I need to add to have that effect? I want to update the particles. I want to keep them moving throughout their lifetime. So under the update context, what I'm going to do is I'm going to add a vector field force. Now you can add whatever vector field that you may have that maybe you created in something like Houdini, but in this case, I'm using the default vector field that comes with the visual effect graph. And you can see it already starts to push the particles out. I'm going to up that intensity to 12. And you see now we're pushing out the particles through the space. So we're done there, and I'm going to go now to our quad output, which is where we determine how the particles are rendered. So right now we have these kind of like clock looking-ish particles are the default particle for the visual effect graph. And what I want to do is change that to be more like kind of like sparks, like to create like a flare effect. So the first thing I want to do is I want to set the blend mode to additive. Now, if, for those of you here who have worked in other software like Photoshop, let's say, you might find this to be very similar with things like layer styles and more. Now, I'm going to change my texture to be from that default particle to this little sparkle texture I have here. It's basically just a little dash of a particle, dash of a texture. And I've added it here. So it's taking on the settings of those circles. So what I want to do is adjust the sizing of those particles to look more like tiny little sparks. So once I add that, another thing I want to do is actually change how they're moving. So right now, they're always facing the camera plane because of this orient face camera plane object. So if I'm walking around or moving around this effect in Unity, it's always going to look at me. But I don't want it to do that. What I want it to do instead is to just follow and face the direction that the vector field force is pushing them in. So I'm going to go here and go to face or orient along velocity. Now I'm going to go ahead and set the size overall for the particles, so I just type in set size. I'll set it to 1. And then I'm going to I want to set the scale now for the particles. So go to set scale. I'll select it for the X value. And I'll have it be 0.3. And then what I'm going to do is set the scale for Y, for the Y value. But I want to set it over life. Because what I want to happen is I want the particle to slowly fade in when it's created, and then as the particle dies, to slowly fade out at the end. So once I have over life selected, I'll just select the Y value here. And I'm going to open this curve graph that I have that I can customize to kind of have whatever I need. But I'll make it straight here. I'll add some keys. And I'll select these two at the ends and bring them down. And I'll multi-select these two and bring them down to maybe about 0.5 as well. All right, so now you can see the particles are like slowly fading out towards the end of their lifetime. Now I want to adjust the scale of the X a bit more. There we go, 0.03. 2. Let's see what 1 looks like. And really that's the fun of the visual effect graph. Going in, tweaking the changes as you go and seeing what works. And the next thing I want to do is we kind of have like the flare happening, but I want to make it be colorful like fire. So I'm going to go to this color alpha over life node here. And I'm just going to select this preset I have. You can customize it to be any color you wish. And now I have a super bright, intense flare ball here that I can use in any projects I have. So this is what we were able to do and achieve together in just, like 5-6 minutes. So imagine the cool things that you can create when you have 10 minutes, an hour, a week, and more. But you can see how simple it is to start building your effects. Now, what I want to do is show you some really cool examples so you can get an idea of what can be achieved. So that Unity logo that we saw in the beginning. Using visual effect graph to create volumetric effects. This cool liquid effect here. Fireworks. All of this is a visual effect graph. We have an effect that generates the particle kind of flying up, and then another one that generates like kind of the explosion of the firework. Doing fluid simulations. I like this one because it reminds me of the enemies in Legend of Zelda that always annoyingly zap you. But again, like this gives you ideas, right? Lots of different ways that you can use it. It doesn't have to be just for a kind of like cool visual in the background. You can actually have it for your characters. You can have it for kind of in the foreground of your scene and more. This cool ribbon pack. I've seen a cool variation of this where people use it to create like vines, scaling up something. I love this one. It's pure visual effect graph radar that came up. If you like any of these and you actually want to see this and like look around and poke around the project, we have all of these project files available at the Unity booth on the Expo Hall floor, so you can go check them out there. Line renderer. I love this morphing face one because it's actually really simple. It's a point cache data scan of somebody's face. And what we're doing is that we're having the particles spawn based on each point in that point cache data. And then at the end of their lifetime, we're using GPU events to change that particle to be a new particle. And in this case, going from that kind of like soft green particle to that sharp metal one and back, cycling through those. Same exact scan, but using, in this case, we have like this bubonic face effect. This is one of the most simplest graphs out there. Pretty much what we have is just, okay, here's the point cache data, spawn those particles on the face, turn them orange, on update, make them grow, and have gravity pull them down. And that's pretty much it for this effect graph. And there's a ton more, and another cool thing is that all of these project files are available to you guys right now through GitHub, and you could download them, tinker with them, see how they look like. And what's cool about them is I'm going to pause here, and I'm going to open one of them up so you can see. Let me try the fireworks one. So you can see in Visual Effect Graph, you can group nodes and context into subgraphs. And here they have titles with information about what's happening in them. And also these cool little sticky notes, which are basically the equivalent of code comments. And these are great for when you're looking at these demos to see how they're made, getting explanation of the context of which everything has been using. So you can see this is a larger kind of effect graph for those fireworks that we saw. But this looks familiar, right? This is almost just like that kind of one batch that we just made earlier. So that's the one thing I think is really cool about visual effect graph. A lot of it can be broken down into easily digestible chunks, and then you add them together to create some really stunning visual effects. So I'll share some news with you all before we wrap up today. So our roadmap. So in 2019.1 for the visual effect graph, we have been working on the lightweight render pipeline initial support for unlit particles only, still for compute shaders also. We also have camera buffer access, static mesh sampling, point cache volume baker, pre-warming of your particles. So I like pre-warming. So if you want to have your particles in a scene that you're working on, and you like the effect that you have, but you want the effect to start like halfway through instead of waiting for it to all just generate out, you can use pre-warming to have it basically play at the part that you're seeking. And then basically with consolidated core functionality is just that in 2019.1, we're focusing on just optimizing it, doing bug fixes and more. And for 2019.2, what we just released today with the 2019.2 release are subgraphs, the ability to create not just subgraphs of your different contexts or specific blocks, but being able to combine those together, make different kinds of node and block combinations to use for your visual effect graphs. So I can save a subgraph in one visual effect and basically import that into another visual effect graph that I'm working on to reuse that same component. So it's really helpful because especially when you're working on in visual effect graph, you might find that you're creating the same effects over and over and over again. When you save those subgraphs, it's going to save you a lot of time. Now, we also have improved integration with the HD render pipeline, having the ability to do render queue selection, exposure control, and distortion output. And also new rendering features like gradient mapping of your alpha textures and new primitives to work with like triangles and octagons, and flipbook interpolations with a motion vector map. Now in 2019.3 is when we're targeting it targeting it to be out of preview mode and available to use in Unity, and also to have shader graph integration, motion vectors, ribbons, and trails to work with as well. But that's my preview of the visual effect for all of you today. If you want to see more, if you want to learn more, I'm going to be at the Unity booth pretty much all day, every day during this conference. And you can check out these demos live in person. You could download them straight from our GitHub. So all these resources here, if you want to get started with visual effect graph, these are my recommended go-tos right here. That general info page is where we're posting the updates about visual effect graph. The visual effect graph samples, everything I showed today and everything that you're going to see at the booth as well, you can download them from our GitHub and play with them and customize them and use them in your own projects so you can get a feel of how to use the visual effect graph. The visual effect graph toolbox is also really useful, especially for those of you here who said that you worked in software like Houdini and such. You can use it. It has a tool to be able to export, so like for example, your point cache data and more from Houdini into Unity to use for your visual effect graph. Being able to handle flipbook textures, so if you want to use 2D animated sprites basically for your visual effect graph, there's a tool for that as well in the toolbox. And lastly, the deep dive blog post. We actually post regular blog posts about cool different things that you can make and how you can make them with visual effect graph. This one linked right here was one that came out recently, and I really like it because it shows how Unity's visual effect graph is being used in kind of a real world scenario for our FPS sample game project. So we're showing how it's basically used in this kind of multiplayer network shooter game. And so I find seeing that context really helpful when I'm developing my effects and not punching my microphone. But yeah, and so you can also go on social media and check out #VisualEffectGraph for lots of inspiration to see what the community's doing. Share what you're working on. We'd love to see it. And the last thing I want to say is that if you're interested in getting your hands dirty with visual effect graph, on Thursday, I'm going to be leading a workshop in this room where we're going to create some effects together. So if you're interested, come on by the Unity booth and you can register for that workshop there. So it's going to be Thursday at 9:30 a.m. But I'm down to my last 5 minutes or so. So if anyone has any questions, I'd be happy to take them. But if not, thank you. Thank you so much, everyone. Go ahead. We are working on the support for VR. I can't say exactly when it's coming, but soon. Yes. Yes. So to see the source code directly, you can get the API for the visual effect graph, and then you can use that to do like the extensions that you'd be interested in doing. Okay. Yeah, or I don't use it. I know of it, but yeah. Okay. Well, one thing that you could do, so he's asking about the ability to use scripting with the visual effect graph. And the one thing I really want to like kind of hit home is that you can control your effect graph through your code. As if you're working on, kind of like, you know, when you're working on a Unity game object, you can affect the values in your inspector. It's the same exact thing. You can have your values in your visual effect graph be exposed, and you could just have them programmatically, like with your code, updated that way. If any of you have seen the spaceship demo or see the spaceship demo at our booth, you're gonna see something that we call a pin screen table, and that's basically heavily using that. Yes? Is that a tool that you use for doing your presentation within Unity available? That actually is available. That you can get that on GitHub. I forget what name it's under, but if you search Unity presentation slides, I think, or in editor, it should come up on a GitHub created by Andy Touch. You can search his name and it should come up. No problem. Hi. Can you write custom operators? Custom operators. Like you had yeah. Facing along velocity, if I wanted to customize that behavior, can I write a custom? I believe in the progress of working on that. Currently, at the moment, no, but soon as well. Yeah. Yes. I couldn't hear. I'm sorry. What's meant by a GPU event? GPU event, basically, GPU event in the context of visual effect graph, at least how I've used it, is basically it detects, you know, when a particle is out of the scene, you can still use that moment to to start rendering something else. Mm-hmm. I have 1 more minute, so maybe 1 or 2 more questions. Yes. Let's talk about that more after. I want to like talk to your question a bit more because I'm not sure I understand completely. But yeah. Okay. You saw some spherical particles, but in your context, I only saw like a quad generation context. So what sorts of meshes can you generate, and what sorts of materials can you use? The mesh. So you mean like for the particles themselves? Like when I made like the whole thing to be a sphere, or just the oh, I see the face. Okay, yeah. You know what? I'm not sure. I actually want to check with the visual effect graph team because I know that they were recently talking about other options for that. So let me get back to you about that as well right after this. And the material on those spheres, that I'm not sure of. Yeah. All right. Well, thank you so much, everybody. I hope you have a great SIGGRAPH.